YouTube, this is my last video in my module on measures of position of data within a data set. In this video we're going to concern ourselves with two things. One, how to determine a measurement which we refer to as the interquartile range. So it's going to harken back to the quartiles of a data set if we split it up into fours. But also this, how to determine if a given datum in the data set is actually an outlier. So we throw this word around a lot, and of course an outlier is just a very large or very small datum that doesn't really match the trend with the rest of the data set. But we can't just say, I think something's an outlier just because I feel that way. I mean, of course, your opinion matters, but we want to come up with some sort of subjective measurement that we can hold this up against and say, look, based upon this this method of measurement, I think it's an outlier. So let's go ahead and start with this, the interquartile range. We're going to define this and start by saying that there's an abbreviation we use for it, but the interquartile range we abbreviate as the IQR, okay? And so the IQR, we define this as being the difference from Q1 to Q3 and is the range of the middle 50% of our data set. So essentially, we care a lot of times about the range of our data, like how far it spans, but most of the time, we don't care about the range of the entire data set as much as we care about the range of just the middle 50% of our data. So we are going to need to determine the values Q1 and Q3 in the first place, and recall that Q1, Q2, and Q3, these are the end of the first, second, and third quartile of our data. So the first thing we need to do is take this data set here, I've got this data set here, and we need to find our 5-number summary, or the values of our min, the end of our first quartile, the end of our second quartile, the end of our third quartile, and then the maximum value. So let's start by putting this data set in order. We seem to have 5 as our minimum, 5, 6, and then we can get rid of those. We say 12, 13 would be next, 12, 13, 15, 18, 22, and 50. And I apologize for not saying what these numbers represent. Usually I put them in a context. But when I'm looking at this, we want to find the interquartile range. First thing we need to do is split this up into 4. So if we count in, we say 5, 50, 6, 22, 12, 18. Looks like we land on two things here. The very first thing we find is the median, and that would be the average of these two numbers. So we say this is our median. It is also the end of the second fourth of our data, or the second quartile. So now, to determine Q1 and Q3, we're going to have to say that we need to find the midpoint of our minimum, which by the way is this 5 right here, and our Q2, and also the midpoint of our Q2 and our maximum, which by the way is this 50 right here. Okay, so we'd say finding the midpoint of these two things, it's very important to recognize that you don't count from the median, but you count from one datum inside the median. So we're going to count from 13 into 5. So 13, 5, 6, and 12. We'd say that the average of these two numbers would be our Q1. So we say the average of those two quickly is 9. And then we say that counting in from the 15 to the 50, because 15 is located inside the median value, we count in, we land on both this 18 and 22. So we need to average their values since we didn't land on a pure value there. So we say this is our Q3. So our 5-number summary pans out thusly. We have a minimum datum value of 5. We say our Q1, the first fourth of our data spans out to 9, and then the first half of our data ends at 14. So 14 is bigger than half of our data, smaller than the other half of our data. 20 is the end of 3/4 of our data. This would be like the 75th percentile. And then we say the very end here, we say the 50 value here would be this upper portion. So when I defined the IQR, this is very easy to find. As a matter of fact, we say IQR, by definition, is just how far the middle 50% of our data spans. And so you'll notice that I say by definition it's Q3 minus Q1. And we say that Q3 is the end of our third fourth of data here. This is 20, and it would be minus the 9. So instead of finding the range, the total distance between 50 and 5, which is the total range, which by the way, the range of this data set is 50 minus 5 equals 45. That is quite the range with respect to the rest of this data. If we were to find the interquartile range, in this particular instance, we just take Q3, which is our 20, and take off Q1, which is our 9. And so we say the range of the middle 50% of our data is only 11 units. Okay, I label this 11 units. We would normally have something to label that with. So IQR, as far as what that is, that's how you calculate it. And you'll see that the middle 50% of the data, is a lot less spanning than the whole data set. And the reason why, by the way, if you haven't noticed already, is that we have this giant value in here, 50. As a matter of fact, if we were to just cut out the 50, and we took 22 instead of 50 minus 5, we would get a span of 17, which is a lot more condensed than we have with this 45. So since we have this 50, what I'm going to do is I'm going to do a couple things here. I'm going to say, is it an outlier? I'm going to question this. Is this an outlier? And so when we say outlier, first of all, we could define an outlier loosely as a very, very large, a very, very small datum with respect to the rest of the data in the data set. So compared to everybody else, they are kind of not fitting the rest of the data. Also this, we want to be able to determine outliers. So this IQR, there's a reason why we want to be able to calculate the interquartile range, but we say that this interquartile range is used to identify outliers. It's helpful, okay? It's also used as a measure of variability and exploratory data analysis, which we get into later, but basically box and whisker plots. So for right now, what I'm going to do is I'm going to walk us through a process that is used often to determine whether something is an outlier or not, and not having to use one's opinion, but actually having a measurement. So we say an outlier, by definition, is an extremely high or an extremely low data value when compared to the rest of the data values. And we say an outlier can strongly affect the mean and also the standard deviation of a given variable, whether that be like height or weight or drive time or something like that. But essentially, we know that the mean and the range and the standard deviation, these can be thrown off by outliers. So we want to determine, do there exist any outliers? So there are several methods for checking for outliers. One of them is to just offer your opinion, but this one is very common, listed below, commonly listed. And we are going to use it. So I'm just going to walk right through the steps here. And this is something you want to get used to, okay? So step one is just this. We're going to arrange the data in order. We're going to find the values for Q1 and Q3. So fortunately, we've already found our 5-number summary. This is our 5-number summary for our data set, okay? So this 5-number summary, we've already found the values of Q1 and Q3, and we actually, step 2 here is find the IQR. So we did this as well. So step 1, we found our 5-number summary. The IQR, in this case, I'm going to write this down over here explicitly, we say is 11 units. Okay, so now what we're going to do is we're going to take this IQR and we're going to take it times 1.5. So we say 1.5 times the value of the IQR. And so basically we're inflating this to be 1.5 times its original kind of, you could call it a geometric length of our data there, the middle 50%. But we'd say that this pans out to be essentially 1.5 times the value 11, which in this particular instance, we could use a calculator for this if we want to. We say 11 times 1.5. 1.5 11s is 16.5 units. So we say that we get this value here, 16.5, and this is equal to 1.5 the IQR. So now, steps 4 and 5. We are going to, on step 4, subtract the value obtained in step 3. So this value that you see right here, we are going to subtract it from Q1. We are going to add it to Q3. So that is, we're going to go to the very first fourth of our data set here. We're going to say this 9. We're going to take 1.5 times the IQR off of that. And we are going to now go to Q3, which is at the end of this middle 50% chunk of data here, this ending point. And we are going to tack on 1.5 times this middle length on top of that. And what we're going to do is we're really going to ask, were there any data values that fall outside this range? Okay, so we could say, all right, so what is this range? So let's go ahead and write Q1. And what we're going to do is we're going to do Q1 minus this 16.5, and we're going to do Q3 plus 16.5. So since this is the beginning of the middle 50% of data, we're going to go 1.5 times the IQR off of that. And so in this particular instance, it seems that we get this Q1, which has a value of 9. We're going to subtract off the value 16.5, and we end up with negative 7.5 here. Okay, so this is, I'm going to give this a name, it's like our lower boundary. Now it's not a boundary in the sense that we use boundary and frequency distributions, but we're going to say this is like the lower boundary. If anything's lower than this, then it would be considered to be an outlier. And then we say, okay, well up here we'd say, let's take our Q3, and our Q3 in this instance, we look up here, we say is 20. We're going to say 20, and we are going to add on the value of 1.5 times the IQR, and in this case we would get a value of 36.5. And I'm going to call this like our upper boundary. Okay, so what we're essentially saying about our data set is this. We say if there are any data values that fall outside of this range from negative 7.5 all the way up to 36.5. Look at the original data set. This is our range of values for which if you were inside this range, you won't be an outlier. So for instance, looking at the original data set, 15 falls between these two things. 15 is not an outlier. We suspected 50 of being an outlier. And the question is, was 50 an outlier? As a matter of fact, since 50 exceeds this upper bound, we would be able to say beyond a doubt, we say 50, let's put it this way, should be considered an outlier. Should be, okay, an outlier. And again, it's because it falls outside that range. As a matter of fact, let me ask this question, but we say, how big would a datum in this data set have to be before we started to consider it to be an outlier, or how small would it have to be? And what I can tell you is any datum that wants to be not an outlier would have to be 36.5 or less, but also -7.5 or bigger. In other words, the biggest you could get in this particular data set without becoming an outlier is 36.5. So if we said, what if I were to say not 50, but 37 up here was our last datum, okay? We would say, okay, well that 37 right there is an outlier because it fell outside of this acceptable range. So these are the definitions of interquartile range, as well as outliers, and as well as how you calculate whether you judge whether or not something is an outlier. Cheers.